Hi, how are you doing today? My name is Brett Norton, and I will be discussing with you high-performance thermoset materials. Let me give you a little bit of background information on how plastic materials are categorized first. Plastic material is divided into two separate categories when heated: thermosets and thermoplastics. Thermosets contain polymers that cross-link during curing and form irreversible chemical bonds. Thermosets cannot be recycled. A good example of thermosetting material is an egg. If the egg is cooked, there is no way to return the egg to its original composition. However, thermoplastic materials soften upon heating and become more of a fluid as additional heat is applied. This curing process is completely reversible. A good example of this would be ice. If ice melts into water, the water can freeze back into ice. Now, let's explore the thermoset category a little more closely now that we have a background with plastics. High-performance thermoset material includes resins, allyls, silicones, high-temperature thermosets, as well as other resins. And the characteristics of high-performance thermoset materials is that they're made with properties engineered for specific purposes and applications. They have low production volume and high costs. This could be due to the fact of making these high-performance materials. They can be more difficult to make and process with their unique properties. In this slide, we are comparing categories of the thermoset materials: general purpose, engineering, and high performance or specialty thermosets for resins, cost, and consumption. Resins, phenol, formaldehyde, and unsaturated polyesters are general purpose here. Polyurethanes and epoxies are engineering, and allyls and polyetheramides are high performance polymers. From viewing the table, you can notice that the cost per pound of specialty thermosets are much higher and the consumption volume is much lower than that of general purpose or engineering thermosets. Allylic resins are high-performance thermoset materials. Some physical properties of this resin is that they have extremely good dimensional stability and almost no post-mold shrinkage. Some mechanical properties are excellent compression strength and impact resistance. Electrical properties are it retains high insulation resistance at elevated temperatures, and its performance is basically unaffected by high ambient humidity. Its thermal properties are that it's good at thermal stability and has no decomposition below 150 degrees Celsius. Its chemical properties is that it's resistant to solvents, acid, alkalis, and fungus, allowing for it to have many applications. The applications of allylic resins is majorly used in the electronic industry. It's used as connections for electronic communications, connections for computers, insulators, potentiometers, circuit boards, switches, TV components, as well as other numerous things. In summary, high-performance thermoset materials have properties that make them more unique than other materials for specific applications. There will always be a need for specialized applications where high-performance thermoset materials would provide the best choice of material. And they are not tied to one industry, allowing materials in other industries to benefit from its properties. And that is all I have. Thank you very much.